Hi guys, we are going to talk about the PERT Math review. The PERT Math can be used for the Algebra 1 concordant score, and if you're planning to go for dual enrollment, you have to take the PERT exam anyways. So let's go ahead and talk about the math section just really quick. We're looking at 30 questions on the PERT Math, and we're really looking at a breakdown of can you solve equations, including linear equations, linear inequalities, quadratic equations, literal equations. Can you evaluate algebraic expressions? Can you work with polynomials, especially factoring, simplifying, adding, subtracting, multiplying, dividing, the four functions there. Dividing monomials and binomials, and then also applying standard algorithms or concepts that just may be used. And then also getting into how do you work with a coordinate plane, making sure that you know those coordinate values, especially through like systems of equations, for example. And then also looking at focusing on pairs of simultaneous linear equations into variables. That's also going to be those systems of equations, trying to find some common value there. So let's start with the first question. The first question says, which of the following is a solution to the equation c plus 4 minus 3c as a quantity, so it's inside of parentheses, minus 2, and it's equal to 0. So here's what we're going to do. We're going to say that we have, let's get my pen on here. We're going to say that we have c plus the 4 minus 3c minus 2 equals 0. All right, this is my first time using the tablet, so you can't make fun of me, all right? So, looking at the set of parentheses, the 4 minus 3c, since there is a positive that's included in front of these parentheses, that means that the signage inside of the parentheses will not change. If this were a negative, it would change the signs inside of the parentheses, but that's not the case here. So we can drop those parentheses, really. So we're going to have actually c plus 4 minus 3c minus 2 is equal to 0. And here's what's really cool. At this point, we can really identify what are the like terms. So we see that we have c and negative 3c as like terms. So c and negative 3c, that gives me a negative 2c. And then I see I have 4 and negative 2. And so if I combine 4 and negative 2, I get a positive 2. And then we can simplify for c by moving that positive 2 to the other side, and then dividing by negative 2, the coefficient value. So negative 2 divided negative 2 is going to be 1. So our answer choice here would be C. All right, let's try moving on to the next one. All right, so this one says graph the solution of y minus 2 is greater than 1 on a number line. So we have y minus 2 is greater than 1. All right, so let's write that down. So the first thing I need to do here is I need to solve for y. So we're going to add 2 to the other side. That's going to be y is greater than 3. So if I'm trying to use a number line to graph, let's get a number line here. I'm trying to use a number line to graph. I know I'm interested in 3. That's obviously a point of interest given this expression. Sorry, given this inequality. So if I have y is greater than 3, I need to look at something. On this side of 3, I have a 4 and values that go upwards. On this side, I have a value of 2 and values that go downwards. So the values that are greater go in this direction. The question is, can I include 3? The inequality is telling me y is greater than 3. It's not possible to be equal to 3. So I have to use an open circle to represent that it is greater than, and it cannot be equal to. Okay? So this is y is greater than 3. So in this case, we go over here to my answer results. And the first one has a solid circle. The second answer has an open circle, and it's going in the direction I need. So my answer here is B. Let's try this third question. So it says, which of the following is a solution to the equation x squared minus 6x plus 5 equals 0? Well, let's write it down. Always start writing off your problem as you see it. That way you know you have an original copy. That way when you start making changes to it, it's right there in front of you. All right, so at this point we need to start factoring because there's no like terms that we can combine. So when we factor, I'm going to get a couple sets of parentheses here. I'm going to use guess and check method. So in this case, what times what would give me x squared? Well, we know that's x and x. The next question is, what times what would give me 5? Well, I only have the option of 5 and 1. So here's what's really cool. When we're reading our trinomial expression up here, the x squared minus 6x plus 5, this little plus on the 5 indicates that these signs of the binomials have to be the same. Because think about it. Positive times positive would give you a positive value. Negative times negative still gives you a positive value. So this is saying that the signs have to be the same. Now this sign over here in front of the negative 6x, this is telling me what signs I'm actually going to be putting in here. In this case, since the signs are the same, I'm going to have both as negative. So there's my factors. Now, there is an additional step. Because we have an equation, because we're equal to 0, and now that we have products, we can use the zero product property. So what we can say is that we have x minus 5 is equal to 0, or, because it's a possible option, x minus 1 is equal to 0. So let's check it out. If I solve this one for x, I get x is equal to 5. If I solve the other side here, I get x is equal to 1. So let's just go back and read that question again, because I got two answers here. So it says, which of the following is a solution to the equation? And it gives me the equation. So I look at my answer choices, and I see that D is one of the answers I solved for. So D would be my answer here. All right, let's look at this fourth question just real quick. So it says, what is the value of the algebraic expression if x is 1/2, y is -1, and z is 2? And so the expression that I have is 6x times, as a quantity, y squared z. Okay, so let's tackle this. We have 6x times the quantity of y squared z. I'm going to cross my z just so we know it's a z, because my 2 looks very similar. And so I'm going to put in some values now, because I know the values of these variables. So I have 6 times, x was going to be 1/2, according to the problem. Now, the set of parentheses around the y squared z, since I'm multiplying everything here, I can technically drop those parentheses if needed. And they're not doing me any good right now, so I'm going to drop them. Now, because my y does have an exponent, I'm going to use a parenthesis here. because y is -1, but I want to square it. And then my z value, we said, was 2. I'm just using parentheses to show my multiplication. So the first thing is, whenever you're multiplying, you can multiply in any order that's necessary if you have multiple products. In this case, we have multiple products. So I'm looking at this 6 times 1/2. Easy way to think about it, what's half of 6? We know that's going to be 3. Excuse that little mark there. -1 squared, that's going to be 1. And then 2 just carries along for the ride right now. So then I multiply 3, 1, and 2, and I get 6 as an end result, which is D as my result. Let's look at this fifth question. So this fifth question says, which of the following is equivalent to 8 minus 5 as a quantity, divide 2 to the third power? Well, you got to think back to those rules from PEMDAS. If you're thinking, oh, I've heard PEMDAS before, please excuse my dear Aunt Sally, you would be correct. You have to think about it though. P, you're starting off with those parentheses. Can you simplify 8 minus 5? Sure, this is going to be 3. And so 8 minus 5 is now 3. We are dividing 2 to the third. E was the next term in PEMDAS, so we're going to deal with this exponent now. 2 to the third will be 2 times 2 times 2. So that's going to be 8. This is 3 divide 8. Now 3 divide 8 is not perfect, but it can also be rewritten as a fraction where it's 3/8 or 3 divide 8. It works the same way. And this is an answer choice for us. So we're going to use answer number A, or answer letter A, excuse me. Let's look at number 6. It says factor completely, and then it gives us x squared minus x minus 6. So I'm dealing with x squared minus x minus 6. Well, since we're factoring, let's get some parentheses. What times what would give me x squared? We're going to say that's x and x. And now 6, what times what would give me 6? I know 6 can either be a 1 and a 2, a 1 and a 6, or a 2 and a 3. Well, because this middle term has a coefficient of -1, let's try that 2 and 3. Now here's the tricky part. If you remember what I said earlier about reading these expressions, these trinomial expressions, when you're factoring, this last sign, if it was positive, told you that the signs of the binomials are the same. But if it's negative, the signs are opposite. So then you got to say, okay, well, wait a minute, where am I going to get my terms so that I can get this middle term and then have the correct signs? Well, check it out. This is a minus x, right? Or a -1 is the coefficient. If I look at my FOIL method, 3 and x here would give me 3x, correct? So I just multiply it out. That gives me a middle term. And then I know x and 2 would give me another middle term, because those are O and I. But I need to get a -1x. So from this, how do I get -1x? Well, I got to have a -3, right? Because 2 would be positive. In this case, where did I get -3? Right here. And here I would get my +2. So there's my factors. And when I look over here, it's not listed exactly like this. It's x minus 3 times x plus 2 is what we got. But they have x plus 2 times x minus 3. Remember, you can multiply in any order. So the answer choice here is C. Let's try question number 7 real quick. So it says simplify the following expression. It gives us 3x to the 4th y squared over xy squared. Well, here's what's really fun. Y squared and y squared, since we're dealing with all products here in the numerator and all products in the denominator, y squared and y squared cancel completely. So they're gone. Now, I can cancel one of these x's with one of the x's in the numerator, and that would leave me only 3 x's in the numerator. So I'm looking at 3 as a leftover term, x to the third, and there's nothing left over. So my answer choice here is A. Let's talk about question number 8 real quick. So it says, which of the following is equivalent to the expression of 3ab times negative 5ab? So 3ab as a quantity. Oops, not quite sure what just happened there. Let's try to go back. All right, sorry about that. Again, first time using this tablet, I must have hit a button and it just left my PowerPoint somewhere in the midst. But we're back now. Okay, so we have, just going over this question one more time, it says, which of the following is equivalent to the expression of 3ab times quantity of negative 5ab? So we're just writing our problem down. We have 3ab as a quantity times negative 5ab as a quantity. Well, 3 times negative 5, that's easy enough, right? It's negative 15. A times A would have to be A squared, and B times B would have to be B squared. So that would be answer choice D. All right, let's look at question 9. Question 9 looks a little interesting because we have a graphic. So it says, what percent of the grid is shaded? Okay, so let's check it out. First off, we have to identify what our grid is made out of. So let's just find out how many boxes we have to the right and how many boxes we have down. So I'm looking, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 boxes to the top, left to right. And going downwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is a 10 by 10 square. And what that tells me is I have 100 little boxes in here, right? Because that would be 10 boxes in every row and 10 rows. So 100 boxes. So we want to know what percent is actually graded. So we know that this column, this column, and this column are fully shaded. So those are 4 columns. That's going to definitely be 40. Here I have 5 boxes that are shaded. So I'm going to have a total of 45% because I'm dealing with 100 total boxes, but only 45 of those are shaded. All right, question number 10. It says, which of the following is the equation of a line that passes through -2, -1, and -4, -3? So they gave me 2 points here. Now, remember, if you're trying to write a linear equation from 2 points, you have to use your slope formula. So we're going to use our slope, which is y2 minus y1 over x2 minus x1. So for our purposes, we'll just go ahead and call this first point x1, y1, and this second point x2, y2. All right, so we have a -3 minus a -1 over, we have -4 minus a -2. Well, remember, minus a negative means you're adding. So we have a -3 plus 1, which is going to be -2. We have -4 plus 2, that's going to be a -2. But -2 over itself is 1. So we have a slope of 1 for this equation. Now, if you recall, from algebra, perhaps, there was a nice little equation called point slope. And the equation is y minus y1 is equal to m, the slope, times the quantity of x minus x1. Well, we now have m, we just solved for it, right? And we have a point, x1, y1, so let's use it. So we have y minus a negative 1 is equal to 1 times x minus a negative 2. Cool. So let's just make this look a little bit better. We know that's y plus 1. We know 1 times anything is just itself, so that's going to be x, and then that's double negative, so that's x plus 2. If we solve this baby for y, we subtract 1 from the left side, and so that will be x plus 1 is equal to y. So that would be answer choice B. All right, let's look at question number 11. Question number 11 says, what is the area of a triangle that has a base of 9 inches and a height of 10 inches? Well, I always like to draw things because I'm a very visual type of person. So here's my triangle. You can't make fun of me. My base is 9 inches, and I know my heights always come down to a 90-degree angle, and my height is 10 inches. There we go. All right. And if you recall, the area formula of a triangle is half of the base times the height. So let's try it out. So we have area is equal to 1/2. We said base was 9, height was 10. All right. Now, if you recall what I said earlier, you can multiply in any order here. So don't get hung up that you don't know half of 9 right off bat. What's half of 10? Well, that would be 5, right? So that would be 9 times 5, which is also 45. But be careful here. We're dealing with area. This was 9 inches, and this was 10 inches. So we have inches times inches, or inches squared. It can also be written as 45 square inches. Both are perfectly acceptable. So when we're looking at our answer choices, we have to make sure we're looking at the correct item. Answer choice A is just 45 inches. That's not correct. Answer choice B is 45 square inches. So it's telling us it's talking about area. And that is our correct answer. Let's move on. All right, question number 12. We have 5 times the quantity of 3 minus 4x is equal to 7 minus the quantity of 4 minus x. So let's start off by writing our problem. And when we're looking at this problem, we're going to go ahead and distribute. So that's going to give me 15 minus 20x right away on the left side. On the right side, think of this minus as like a negative 1, if it helps. So I'm going to have 7 minus 4 plus x. Notice that sign change. That's a negative 1 times a negative x. All right. Now let's combine any like terms that we have. Then we'll start moving from side to side. So the left side did not change. The right side, we have 7 minus 4, which is 3. And then we can say, all right, let's add that 20x, excuse me. And you're going to get 21x. Jumping the gun here. And if I subtract 3, this side will go to 12. Well, solving for x, I have to divide by 21, so I have 12 divide 21. But I have to ask myself, can I simplify this at all? Well, 12, that's 3 and 4. 21, that's 3 and 7. So yeah, the 3's can cancel. And that would leave me 4/7 as my x value, which is answer choice C. Ooh, the dreaded fractions. Question number 13 says solve for y and they give us fractions. Fractions are friends. Don't let them scare you. So we're going to go ahead and write this problem down. It says 3/4 plus y is equal to 5/3. And then from here, we know we're solving for y, so I'm going to move this 3/4 over. So that's y is equal to 5/3 minus 3/4. Now here's the problem. My fractions do not have a common denominator currently. So I'm looking at 3, I'm looking at 4, and I'm saying, what is the first multiple that they actually have in common? Well, that would be 12. So my least common denominator here is 12. So the question then becomes, well, if this is currently a 3, how do I make it a 12? Well, I have to multiply by 4. Okay, so let's check it out. I know I have to multiply this term by 4 in the denominator, but what I do to the bottom, I also must do to the top. Let's do over here. We have 3/4. I have to multiply this by 3/3 to get that 12 as my common denominator. So, looking at this again, let's clean it up. I know my denominator is going to be 12 here. 5 times 4 is 20, minus 3 times 3 is 9. 20 minus 9 is 11. 12 did not change. So y is 11/12, or answer C. Let's move on. Decimals. All right, you got hit with a double whammy because you had fractions and now you have decimals. So let's try it out. It says solve for z, and we have 5.6 is equal to 0.02z plus 7.38. Now, if you're sitting there and you're like, oh my gosh, I fail. I give up, right? Don't worry, we're going to save you. Here's how it works. So we have 5.6, right? Get my cursor on here. Here we go. We have 5.6 is equal to 0.02z, I'm going to cross my z, plus the 7.38. Now, I noticed that in the first part, 5.6 only has one decimal place. 0.02z has 2 decimal places. 7.38 also has 2 decimal places. So why don't we clear those decimals out? Why don't we get rid of them? Because I know everybody loves decimals, right? So here's how we're going to clear. We're going to multiply everything here on the entire problem by 100. What that's going to do is 5.6 times 100 is now 560. When we're multiplying over here, that's going to give me 2z. When we're multiplying over here, that's going to be 738. When I subtract my 738 to the other side, I have 2z here. Cross that z. On this side, I'm going to have a negative 178. Now, divide by 2 because I want to solve for z here, right? So I divide by 2. Negative 178 divided by 2. Oh, that's crazy. Well, think of it as like a negative 180. Half of that is like negative 90, but it's 1 less, right? Because it's actually 2 less. So it's really more like just a negative 89. It's not that bad. You just got to use your skills. So answer choice D is our correct value here. Let's try the next one. This is question number 15. It says Best Buy, my favorite store because it has lots of toys. So Best Buy is selling a television for $1,250. Sales tax in Lake County is 7%. Using P as the amount I will have to pay for the television, including my sales tax, write an algebraic equation, that describes this transaction. Well, all right, I know I have to pay something because, they're not going to let me walk out with a TV for free. I wish. Tell them I'm a teacher. They should give me a discount, right? All right, so here I have P. That's the price I'm going to pay. I know I have to buy the TV, and I know I have to pay sales tax. So I'm going to use TV for representing the price of the TV, sales tax representing the cost of the sales tax. Well, the TV was told to me to be $1,250. And I know sales tax is 7%. Now here's the thing. 7% of the actual cost of the TV is the sales tax I have to pay. So we're going to rewrite this as 0.07 times 1,250 because I have to pay 7% on the 1,250 for the TV. That's how they charge sales tax. So that being said, let's just go back to our formula here. We said P is equal to the TV plus the sales tax. And that is actually going to be an answer choice C. Question 16 says we have 4x times the quantity of 2y plus 3z minus 12, and it says multiply and simplify where possible. So let's check it out. If I have 4x, it's a monomial term, times this trinomial of 2y plus 3z minus 12, and I'll cross that z. There we go. Well, I can technically distribute here, so that would be 4x times 2y, that's 8xy. 4x times 3z, that's 12xz, cross my z. And 4 times negative 12 is going to be a negative 48. Don't forget the x. And so we look, do we have an answer choice? Yes, we do. Right there. Answer B. All right, let's move on. So, question number 17 tells us that we are multiplying and simplifying where possible. Same instructions as the last problem. But this time they gave us a binomial and another binomial. Now, there's a couple things that we could do here, but I'm going to use the FOIL method. So, I'm looking at 5x minus 2 times 6x plus 3. Now, just in case you're not familiar with FOIL, this is how it works. FOIL multiplies the first terms, that's your f. We can write an f, here we go, yep, all right. So that's going to be 5x times a 6x, okay? So there's f. O is going to be your outer terms right here, so that's O. So that's going to be plus 5x times 3 I, which is going to be your inner terms. So that's going to be minus 2 times the 6x. And then your L, your last terms of the binomials, will be a negative 2 times 3. So this is FOIL. Now let's just simplify it. Let's see what we got. Let's clean it up. So 5x times 6x, we get 30x squared. 5x and 3 will give me positive 15x. Negative 2 and a positive 6x will give me a negative 12x. And negative 2, positive 3 is a negative 6. At this point, I look to see, do I have any like terms? And the answer is yes. Yes, I do. Right here in the middle. Because they're both like terms. They both have x to the first degree. So we're going to combine those coefficients. I have 30x squared plus 15 and negative 12 gives me 3x. And then minus 6 just goes along for the ride. I ask myself, do I have an answer choice here? And the answer is yes. Yes, I do. All right, this one just gives us the very simple instructions of simplify. Let's try it. So I have z squared plus 3 plus as a quantity plus the quantity of 4z minus 7 minus the quantity of 5z squared plus z minus 9. All right, let's start clearing some stuff up, okay? So when we're looking at this problem, we have z squared plus 3 as a quantity, plus we have 4z minus 7 minus the quantity of 5z squared plus z minus 9. Well, let's talk about these parentheses for just a minute because we got a lot of parentheses. It can go everywhere, right? Well, is there anything we can simplify in the first set of parentheses? The answer is no. No, there's not. There's no like terms here. And there's also no sign change that's occurring because I don't see anything preceding these parentheses that would change the sign. So we're going to go ahead and just drop those parentheses. Just get rid of them. So that's z squared plus 3. Moving on. Looking at 4z minus 7 as a quantity, is there anything that I can do to simplify? No, still no like terms. And because this is positive in front of the actual parentheses, no sign changes will occur. So I'm going to drop those parentheses too, just because I can and I want to. There we go. Last set. Is there anything inside of the parentheses that we can simplify? The answer is still no, no like terms. But I do have a negative that's sitting in front of those parentheses. So I got to be careful. I got to distribute that out as if it's like a negative 1. And so that's going to change my sign. So that's going to be a minus 5z squared minus z plus 9. So watch those signs. Ask yourself, do you have any like terms? I see this is a like term with this. So I have z squared and negative 5z squared. And that's going to give me a negative 4z squared when I combine those. I see that I have 4z and negative z. So it's going to be a plus 3z. And then I see that I have a 3, a negative 7, which is negative 4, and a 9. So positive 3, negative 7, we said was negative 4, plus 9, it's going to be plus 5. Ask yourself, do I have that answer choice? Yes, you do. Time to move on, people. Question number 19. Very simple. It says simplify. Love when they say directions in just one word. So we have 2 times the radical, which is technically a quantity, but it has a process to it. So 2 times the radical of 18a squared x to the 5th. We're going to talk about those variables in just a moment, so don't freak out just yet, all right? Now, if we're looking at 18 can break down, right? I'm just going to write that too. I'm going to extend my radical here. 18 is 2 times 9, right? Yeah. So 9 is 3 and 3. Now I'm writing this all the way out because it's 3 times 3, that's the 9, times 2, that would still give me 18. That works out. When I write out a squared, it's a times a, right? And then when I write out x to the 5th, it's x times x times x times x times x. All right. Here's what's really cool. We're dealing with a square root. Now, square roots have this cool little feature. It's kind of like playing poker. And so what you get to do is you look for 2 of a kind. Well, check it out. There's 2 of a kind. There's 2 of a kind. There's 2 of a kind. And there's 2 of a kind. So I can pull out a 3, an A, an X, and an X. Because there's my 3, there's my A, there's my X, there's my X. So these are all gone. So let's go ahead and just cross those out. What I have left is 2 and X inside of the radical. Now, you can't forget about this 2, so it's just going to come down for the ride, okay? Now, let's clean it up. Let's make it look better. 2 times 3, that's 6. A, x times x is x squared. We have a radical of 2x left over. So, 6ax squared, I read it too quickly, times the square root of radical 2x. And that is an answer choice. So let's move on. Question number 20. Oh, there's no numbers. What do I do? Danger, Joe Robinson, danger. Actually, you probably don't catch that reference, but that's okay. Makes me feel a little old. So it says solve for x. We have ax plus by is equal to c. Well, if I'm solving for x, the first thing I need to do whenever I solve for any variable is find out where is that variable. If you're solving for it, kind of helps to know where it's at, right? So let's check it. There's my x. Beautiful. Do I care about the by at all? Meaning, does it have an x? Does it have something I'm solving for? The answer is no. Get rid of it. Be like, all your stuff is over to the right, in a box to the right. What? All right. So we have ax is equal to c minus by, because we just totally pulled a Beyonce move. We moved all of that by to the box to the right. Excuse me. So at this point, we're solving for x. Still solving for x. And I have ax on the left, c minus by on the right. I don't care about the a, and I'm multiplying, so I'm going to divide it out. So I have x is equal to c minus by divided, all of that divided by a. And that is an answer choice for me. Let's talk about question number 21. 21 says solve for x, and it tells us that we have 4x squared plus 4x minus 35 is equal to 0. Now, this problem can look intimidating to start with, but it's really not that bad. So let's try it out. So if I happen to have this particular trinomial, and I have to go through and say, all right, let's factor it and see what we get. Don't forget to keep equaling 0. It's a very important piece. We'll come back to it. So what times what would give me 4x squared? Well, how about 2x and 2x? And then what times what gives me 35? Well, think about it. 7 and 5. Cool. So if you remember the little trick I showed you earlier, it's kind of using that FOIL method, but just really looking at O and I. We're looking at how do we find that middle term, because the signs here are still eluding us. And we see that the negative 35 tells us that the signs of the binomials would have to be different, but this positive 4x is kind of throwing us off a little bit. So we're like, where does the sign go? So check it out. If we multiply our I, that's 7 and 2, right? That's going to give me 14x. If I multiply my O, that's my 2 and my 5, that's going to give me 10x. The question is, how do I get 4x, positive 4x, from these two values? Well, I have to get rid of the 10, right? I have to subtract the 10 from 14. Okay, great. So where did we get 10? So we had 2x and we had 5 when we multiplied. So this is where I can put in a negative, because 2 times negative 5 gives me negative 10. That works. Positive 14, well, if I put a plus here, that gives me positive 14, so that works. Now there is an additional step here. An additional step being that we have two products equal to 0. So either 2x plus 7 is equal to 0, or 2x minus 5 is equal to 0. All right, let's solve. So this is going to be 2x equals a negative 7, or x is a negative 7 halves. Over here, I have 2x is equal to 5, or x is equal to 5 halves, positive 5 halves. So is that an answer choice? Well, I have negative 7 halves, and I have positive 5 halves. So yes, that is an answer choice. Moving on. So we have 5x minus 8 is less than 11x minus 2, and it says solve for x. Okay, pretty straightforward, right? So let's just move this 5x over. I like to keep things positive. So I'm going to move my 5x to the right side, which gives me 6x here. At the same time, I'm going to move my 2 to the left side, and that'll give me a negative 6 here. Cool. Divide by 6 because I'm solving for x. And then I'm just going to flip it around because sometimes people just like to read variables on the left. Who knows why? But when we're looking at it, we flip this over. We do a mirror flip, so we just flip it completely over. We have x is greater than negative 1. Question is that an answer choice? And there you are. All right. Question 23 is pretty cool. And question 23 tells us to simplify. And then they give us radicals. I mean, what were these people thinking, right? Well, hate to break it to you, but I wrote this. So what was I thinking? That I wanted to challenge you and make you better at radicals. That's what I was thinking. So let's try it out. We're going to simplify. So we have the square root of 12 plus the square root of 48 minus the square root of 27. Can 12 break down? And what I mean by that is, can we get something that is a perfect square root? The answer is yes. 12 is technically 4 times 3, right? And 4 is a perfect square root. So we have that as 2 square root 3. Cool. Let's try 48. So 48, can it break down? Think about it. It'd be 16 times 3, wouldn't it? Is 16 a perfect square? Sure. So that would be 4 square root 3. Let's try 27. 27, 9 times 3. Cool. Is 9 a perfect square? Yes. So it would be 3 square root 3. Notice I just kept my signs the entire time, and I worked one piece at a time. Very simple, very straightforward. Now, when you're adding or subtracting radicals, you have to make sure that the radical is exactly the same in everything you're adding and subtracting if you're planning to combine those terms. So we have 2 square root 3 plus 4 square root 3, so common terms there, common radicals or like radicals. So 2 and 4 would give me 6. That minus 3 radical 3, I'm going to just carry it for a moment. So I just added my coefficient values. At this point, I asked myself, 6 square root 3 minus 3 square root 3. Do I have common radicals again? Yeah, I do. So 6 minus 3 is 3. Square root 3 just tags along for the ride. So that's answer choice D. Let's try the next video. Or sorry, the next question, not the video. I'm making a video. All right. So we have solved the system of equations. They give us 3x plus 5y is equal to 3. And then they give us x is equal to 8 minus 4y. Just going to get my equations up here real quick. Beautiful. So if the first equation is saying that 3x plus 5y is 3, it's equal to 3, and it's saying that the second equation, x is 8 minus 4y, then couldn't I take this 8 minus 4y and substitute it for x? Why not? Let's try it. So 3 times my new x value from the second equation plus my 5y is equal to 3. Check it out. I no longer have x's. I just have y's. How cool is that? So we're going to go ahead and do this. Distribute. That's 24 minus 12y plus 5y equals 3. That's 24 minus 7y equals 3. Just combining like terms. If I subtract that 24 over, that's a negative 7y is equal to a negative 21. Divide by negative 7, y is 3. Cool. So I got y is 3. But what is x? Well, we have x is equal to 8 minus 4y, right? But y is 3. So let's try it. So x is equal to 8 minus 4 times 3 is 12. So 8 minus 12 is a negative 4. Now, whenever you're dealing with systems of equations, if you get x and y values, we always write them as a coordinate. So we have x is a negative 4, y was a positive 3. So there's my result, negative 4, 3. Is that an answer choice? Yes, it is. Move it on. Another one-word problem. It says simplify, and it gives us x squared plus 9x plus 8, all of that divided by x squared minus 3x minus 4. Okay, pretty handy. Let's do it. I'm going to suggest that we start by factoring each one of these pieces. So let's just write our problem out just real quick and then look at what factoring might do for us. So if I try to factor, I'm going to move to this side for a moment. I try to factor this top. I know I have x and x for x squared. Let's try 8 and 1 to get 9. The signs are the same, so they're both positive. Beautiful. Let's try the bottom. So x and x, that's my x squared. 4, I'm going to say let's do 4 and 1. Now 4 is negative here, so that means my signs are going to be opposite. I need a negative 3. And if you've started to see that trick, how it fleshes out, it's telling me that the greater term is going to get this sign. So it's going to be a negative 4 and a positive 1. Cool. Now here's what's really awesome about fractions. If you have one piece that can cancel with another piece, cancel it. It goes away. I have here x plus 1 over x plus 1. So those will cancel completely. And that leaves me x plus 8 over x minus 4. Is that an answer choice? Yeah, buddy. So we're going to move on. Question number 26. We have y squared plus 10y plus 25, all of that divided by y squared minus 9, excuse me. And all of that is multiplied by another fraction of y squared plus 3y divided by y plus 5. That's a lot. But we're going to take it piece by piece. So we have y squared plus 10y plus 25 over y squared minus 9, y squared plus 3y, y plus 5. All right. So we're going to factor. Factoring is really, really fun. That's why it starts with an F. So we know we're going to get y and y. 5 and 5 for 25. Both signs are going to be positive here. Now, y squared minus 9, keep in mind that is a difference of perfect squares, or difference of squares. So we get the same terms in either binomial, so y and y, 3 and 3, but you get opposite signs. Over here, the denominator doesn't factor at all, and the numerator only has a greatest common factor of y, or GCF of y. Awesome. Now let's look and see if there's anything that can cancel. In this case, y plus 5 and y plus 5 can cancel. Y plus 3 and y plus 3 can cancel. So I'm left with y plus 5, all of that over y minus 3. Is it an answer choice? You betcha. So let's move on. Question number 27, another one-worder. It says simplify, gives us a fraction minus another fraction. So let's look at those fractions. We have x over x squared plus 9x plus 20 minus 4 divided by x squared plus 7x plus 12. Something tells me we're going to have to factor here, so I'm just going to factor just real quick just to see what this looks like. And so I get my factors on the first part. Looking at my second part, and so from here I'm like, okay, I don't have common denominators, but what do I need on the first part? Well, I need an x plus 3, don't I? What I do to the bottom, I do to the top. Second part, I need an x plus 5. Same rule. What you do to the bottom, you do to the top. And so this would give me x times x plus 3 minus 4 times x plus 5. All of this over x plus 3, x plus 4, x plus 5. Now, don't jump the gun and say, oh, it's the only one that has all 3 pieces, and so I'm just selecting an answer choice. Don't do that. You're not done with the problem yet. You gotta see, does that actually hold true? So let's look. X times x plus 3 is going to give me x squared plus 3x. Minus 4 times x plus 5, that's going to be a minus 4x minus 20. Denominator did not change. Combine like terms here. I'm going to get x squared minus x minus 20 over that same LCD. I'm just going to write LCD for just now, for quick hand, if you will. And then I'm going to say, can I factor this? Well, let's look. 5 and 4, possibly. Possibly -5, +4. And I look at my LCD. I'm just going to write that back in now. Is there anything that can cancel? Right there, x plus 4 goes away. So I have x minus 5 over x plus 3, x plus 5. So if you didn't watch this whole problem, or you just jumped the gun way back here where you saw 3 parts in your denominator, that would be wrong. So you got to solve it all the way out. And yes, you do get an answer choice. It is C. Let's move on. So question number 28 says, if f of x is equal to 4x squared minus x plus 3, find f of -2. All right, let's just recap really quick. F is the name of the function. That's it. X is the variable. So in this case, x is now going to become the -2. So that's what we're looking at. So let's try it out. So f at -2, I'm just going to go ahead and substitute this in. 4 times my -2 squared minus, notice I'm using parentheses. I'm doing parentheses really as more of a practice than just for the negative sign, but it's best to do it as a practice, honestly. That way, if you're looking for something consistent, it works every time. All right, at this point, let's simplify what we got. So -2 squared is a +4. Double negatives here is +2. Plus 3 is tagged along. 4 times 4, 16. 2 and 3 is 5. And so this gives me 21. '29 says, write a linear equation in slope-intercept form that is perpendicular to y equals 3x minus 4 and crosses 3, 6, the point 3, 6. So here's the thing. If we're looking at this problem that they gave us, y equals 3x minus 4, the slope here is 3, right? But I don't want that slope. I want to know what is the perpendicular slope. Big difference. Big difference. So I'm going to look for perpendicular slope. That's what this little upside down T means. Perpendicular. So perpendicular slope has to be opposite in sign. This was positive. This must be negative. And it has to be the reciprocal. So this is 3. Technically, it's like 3 over 1. So this would have to be 1 over 3. So this is the slope that I'm going to use. Now, if you recall from earlier or from algebra, we can use point slope form to find our equation. So we're going to have y minus 6. 6 is coming from the point. Our slope is -1/3 x minus from the point 3. Awesome. Now let's distribute. So y minus 6, that didn't change. This is a -1/3 x. And what's a third of 3? 1. Negative and negative makes it positive. Add our 6 over. Y is equal to a -1/3 x plus 7. So there's your equation. And last question, question number 30. It says simplify, put in rationalized form. Ooh. So I have 8 over the square root of x plus 2. The square root of x is separate from the plus 2. So when I'm looking at this problem, To rationalize, what I have to do is use the conjugate of the denominator. Now, let's talk about this for just a second. Conjugate is the same exact terms, okay, so it's going to be square root x and 2, but it's going to be the opposite in sign. Now, if you notice, this kind of looks like a difference of squares. So difference of squares and conjugate, same concept. It works. So let's try it out. What you do to the bottom, you do to the top, and we are multiplying the square root of x minus 2 to both parts. The top, just distribute. That's going to be 8 square root x minus 16. The bottom, if we multiply it out, square root of x times square root of x is square root x squared. You have to FOIL here. If you don't see the shortcut, you have to FOIL. Minus 2 square root x plus 2 square root x minus 4. But check it out, those middle terms, they go bye-bye. Square root of x squared is just going to be x minus 4 here. Top did not change. So you have 8 square root x minus 16 over x minus 4. Ask yourself, is that a choice? You betcha. All right, guys, I hope you found this very useful. Make sure that you are studying for that PERT. If you have any questions, feel free to stop by and ask me. If you want to stop by the Media Center, sometimes I'm up there. I know for the PERT review week, I'll be up there as well, and Miss Mendoza will be as well. So feel free to stop by, ask questions. Catch you later, and happy studying.